Bird brains, I say. Each year, approximately 1,800 different bird species migrate distances as large as the Earth's diameter. Miraculously, these birds follow a very similar pattern each season they migrate and often arrive at the exact same location as though they have an inbuilt GPS. Turns out that might not be far from the truth. Birds use landmarks, the position of the stars and the sun, and the most interesting in my opinion, the Earth's magnetic field in order to navigate. So what sort of magical quantum compasses do birds possess? Here is an avian eye. Some might call it a bird's eye view. And inside the retina's cone cells, we find a protein called Cry4. Inside this protein are two molecules called FAD and TRPH that I've represented with single atoms to simplify. Both have an even number of electrons in their outermost shell, so the electrons form pairs called Lewis pairs. The thing about all electrons is that they actually behave like tiny magnets due to something known as quantum spin. Electrons in each pair need to have opposite spins so that they cancel out each other's magnetic moments. You can think of it like two people with massive heads trying to fit inside a small elevator. The only way to fit is if one of them turns upside down, so they are now anti-parallel. When blue light enters the bird's eye and hits FAD, it enters an excited state and one electron jumps from TRPH to FAD. This breaks the Lewis pair in TRPH and causes both compounds to now have one unpaired electron, hence they become radicals. These unpaired electrons now have weak magnetic fields around them because there's nothing to cancel them out. And just like a compass needle is a tiny bar magnet and aligns with the Earth's magnetic field, they too now align with the geomagnetic field, and their spins become parallel. However, this alignment only lasts for less than 1 microsecond and depends on the strength and direction of the magnetic field. But in that tiny amount of time, it prevents the electron on FAD negative to jump back to TRPH positive because the two electrons don't have opposite spins necessary for a Lewis pair. Because this electron alignment prevents the electron from going back, it triggers a different chemical reaction, which causes an electric signal to travel down the optic nerve of the bird into a part of its brain called cluster M. Here the signal is processed and the bird is able to visualize the magnetic field lines of the Earth. What I find most interesting is how something as small as the spin of an electron that may as well be considered a molecular tongue of slip can lead to an entire new sense for a living organism. What's even more fascinating is that though the theory I explained in this video is the leading theory on magnetoreception, it is still not confirmed, and the next breakthrough in quantum biology is likely to come from this very field. But until the theory catches up, one thing's for sure. Migratory birds have an incredible sixth sense. Bird brains, I say.